Welcome. In this video, we're going to use first principle to find the derivative of the function 1 over x. F of x equals to square root of x. F of x equals to x plus 1 to the power of 1 over 2. F of x equals to exponential x. F of x equals to 2 to the power of x. F of x equals to exponential x plus 1. F of x equals to 2 to the power of x plus 1. To use first principle to find the derivative of the following. By definition, limit h approach 0 f of x over h. F prime of x is equals to limit h approach 0. Limit h approach 0. Anywhere there is x, plug in x plus h. X plus h minus 1 over x over h. This is the same thing as the limit h approach 0. What is the LCM of the denominator? X plus h. Here will be x minus x plus h over h. This is the same thing as the limit h approach 0. X minus x minus h over x into x plus h over h. Minus x will cancel. This is the limit h approach 0 of minus h over x plus h divided by h. The limit h approach 0 of minus h over x plus h multiplied by 1 over h. The reciprocal of division is multiplied by 1 over h. The limit h approach 0 of minus 1 over x plus h. Plug in when h equals to 0 to this function, the denominator will not be 0. So this is equals to minus 1 over x plus 0 minus 1 over x squared. So by first principle, the derivative of the function 1 over x equals to minus 1 over x squared. This is the same thing as minus x to the power of minus 2. F of x equals to square root of x. To use first principle to find the derivative of the function f prime of x, the derivative of this function using the derivative definition. This is equals to anywhere there is x, plug in x plus h minus the original function over h is 2. From this step, rationalize this. To rationalize the numerator is to multiply it by 1. The limit h approach 0 square root of x plus h minus square root of x over h multiplied by the square root of x plus h plus square root of x over square root of x plus h plus square root of x. Here is negative. To rationalize, 1 will be positive. If here is positive, here will be negative. This is the same thing as the limit h approach 0. Multiply the numerator wisely. X plus h minus square root of x plus h plus square root of x x plus h minus x over h. Square root of x multiplied by square root of x. This is the same thing as x to the power of half, x to the power of half. X to the power of half square. This is the same thing as x to the power of 2 over 2, which is just x. Square root multiplied by square root, this is going to be just x. So anything in square root multiplying each other is going to just be this term will go away with this term. X minus x, the term remain h. So h from the numerator, h square root of x plus h plus square root of x. H will go away with h. So the limit h approach 0 of 1 over square root of x plus h plus square root of x. Plug in h equals to 0. The denominator will not be 0. So here will be 0 plus x. H approach 0 of 1 over square root of x plus square root of x. This is 1 over square root of x plus square root of x, which is going to be 1 over 2 square root of x. So the derivative of the function is equal to 1 over x. This is the same thing as 1 over 2 to the power of 1 over 2. Given the function f of x equals to square root of x plus 1, to use first principle to find the derivative of the function, square root of x plus 1, limit h approach 0. Anywhere there is x, plug in h plus x plus 1 minus the original function over h. Since this function is in square root, the next step is to rationalize by multiplying the numerator and the denominator with special 1 multiplied by 1. This one is going to be the rationalize of the numerator because the function is in square root. X plus 1 over h multiplied by square root of x plus h plus 1. In this case, it's negative. The rationalize will be plus x plus 1 over. So multiply the numerator and the denominator. Square root multiplied by square root is just going to be what is under the square root minus the second term will cancel the third term. Then the fourth term minus square root of x plus 1 multiplied by square root of x plus 1 minus x plus 1 over h square root of x plus h plus 1 plus square root of x plus 1. Limit h approach 0. Use negative to open the bracket. X will cancel minus x. 1 will also go away with 1. Left with h over h square root of x plus h plus 1 plus square root of x plus 1. Limit h approach 0. 1 over square root of x plus h plus 1 plus square root of x plus 1. Let h equals to 0. The denominator will not be 0. This is equal to the limit h approach 0 of 1 over x plus h plus 1 plus square root of x plus 1. This is just 1 over square root of x plus 1 plus square root of x plus 1. 1 over 2 square root of x plus 1. This is the same thing as 1 over 2x plus 1 to the power of 1 over 2. You can also rewrite it as 1 over 2 x to the power of minus 1 over 2. So given the function, the derivative of square root of x plus 1 is equals to 1 over 2 square root of x plus 1. Use first principle or use definition of derivative to find derivative of the function 2 to the power of x. Solution. To find the derivative using the definition of derivatives, 2 to the power of x, this is the same thing as the limit h approach 0. Anywhere there is x, plug in x plus h minus the original function over h. The limit h approach 0 by law of indices, this is 2 to the power of x multiplied by 2 to the power of h minus 2 to the power of x over h. The limit h approach 0, 2 to the power of x is common, left with 2 to the power of h minus 1 over h. 2 to the power of x can be factored, there is no h. 2 to the power of x, the limit h approach 0 of 2 to the power of h minus 1 over h. This is equals to 2 to the power of x multiplied by to the power of h minus 1 over h is equals to 2. So the derivative of the function 2 to the power of x is equals to 2x ln 2. So factor 2x out. What is this limit? 2 to the power of x ln 2. By definition, so the derivative of the function is equals to 2 to the power of x ln 2. Find the derivative of the function f of x equals to 2 to the power of x plus 1 using definition of derivative. F prime of x is equals to 2 to the power of x plus 1 limit h approach anywhere there is x, plug in x plus h plus 1 minus the original function over h. This is the same thing as the limit h approach 0, 2 to the power of x plus 1 plus h minus 2 to the power of x plus 1 over h. The limit h approach 0. This is the same thing as 2x plus 1 multiplied by 2 to the power of h minus 2x plus 1 over h. Law of indices. The target is to factor, rewrite this in terms of 2x plus 1 so that you can factor 2 to the power of x plus 1 out. Limit h approach 0, 2 to the power of x plus 1, 2 to the power of h minus 1 over h. 2 to the power of x plus 1, there is no h approach 0. To the power of x plus 1, limit h approach 0 of 2 to the power of h minus 1 over h. This is equals to 2x plus 1 ln 2 because the limit h approach 0 of this expression is equals to 1. So the derivative of the function 2 to the power of x plus 1 ln 2. F of x equals to y equals to exponential x. To find the derivative using definition, f prime of x is equals to exponential x. The limit h approach 0 of the function, anywhere there is x, plug in x plus h minus the original function over h. the limit h approach 0, exponential x multiplied by exponential h, law of indices, minus the original function over h. This is the limit h approach 0. Factor exponential x is common. Exponential h minus 1 over h. This is the same thing as exponential x, the limit h approach 0 of exponential h minus 1 over h. Exponential x multiplied by 1 because by definition the limit h approach 0 of exponential 1 over h is equals to 1. So the derivative is exponential x. F prime of x equals to the exponential x. The derivative is equals to exponential x. Given f of x equals to exponential x plus 1, to use definition of derivative to find the derivative of the function exponential x. This is the same thing. Limit h approach 0 of exponential x plus h plus 1 minus the original function over h. Limit h approach 0 exponential x plus 1 plus h minus exponential x plus 1 over h. Limit h approach 0 exponential x plus 1 multiplied by exponential x plus 1 over h. The limit h approach 0 of exponential x plus 1 is common. Exponential h minus 1 over h. The same thing as exponential x plus 1, the limit h approach 0 of exponential h minus 1 over h. Exponential x plus 1 multiplied by 1. The limit of this is equals to 1. So f prime of h is equals to exponential x plus 1. Thanks for watching. This is all for this video. In the next video, we're going to use first principle to find the derivative of exponential of x squared. Then the power rule. We are going to see how the power rule, the product rule, sum of function rule, chain rule, and implicit differentiation.